Today we're going to do a tutorial from SolidWorks. This tutorial can be found from Help menu, Tutorials, go to SolidWorks Simulation Tutorials, and when you click Mixed, Solid and Shells, then you will be able to see this instruction. Today we're going to complete this tutorial. Let's get started. This tutorial we will learn how to define shell property and also add link connectors. By click this button, you will be able to see the next page. Okay, you can either click here to open the file, or you can copy the link. Let's click here, then the file is opened. You can see there are two files being put in this assembly. The first component is the solid, the second component is shell, which is this one. Because we don't want to change the original file, so let's save as into a new location. Also put my initial here, and also let me see if we can open this file. Here's the mixed one solid. You can see there are some things have been made already. We can switch back to our assembly. Let's look at this shell. Okay, you can see, right? No material been assigned to this one, mixed one. Okay, let's go back to assembly. You can see there are three components or three files being opened. Let's go to here. Follow the instruction. New study. Go to simulation. New study. I'm going to make mixed mesh as a new name. Static. It's okay. Now you can see mixed mesh is displayed here, and you can also see this. Okay, so expand. You can see here's a shell, here's a solid. Mixed shell, solid. Click property. Click property, and it says the solver should be set to direct sparse surface server, direct sparse server. Hit OK. All right. Then we will be able to add a definition of the shell in the simulation start tree under the parts. Right click the shell icon, right click, and edit definition. You can see here, this is a definition. We would like to make this one to be millimeter, and the unit will be 5. 5 5 thickness. Hit OK. And then we need to apply ductile iron for this material. So we can right click the shell. You can see here material, edit material, search for ductile iron, hit apply, hit OK. You can see, scroll down, ductile iron being assigned to here. Open it. You can also see it in this single file. Go back to assembly. Then let's apply ductile, right? Edit the material. So ductile iron, same material being used. Open it to check. Yes, this is the material we're going to use. What's next? We're going to add the 3 psi pressure. We already learned this one in our tutorial last week. So go to here and external load, right? So what we can do here, right click, pressure. Okay, so click the surface and then unit psi, and it's 3 psi. Okay, right. So this is a pressure, and then add a fixed restraints to the cylindric. So we're going to fixture, right click, fixed geometry, select cylinder 1, 2, 3, 4, 5, 6. Hit OK. Now we're going to create a link. The link will make this 2 point and this 2 point relatively no movement, right? So right click connectors, okay, right click connectors, and we're going to have a link. So link, so the first point is this one, and the second point is this one. Hit apply. So we have one link here, right? So we're going to create another one. Same type, link. We're going to select this vertex and vertex 2. Hit OK. Now we have 2 links. Alright, so You can see here, this contact is bounded, right, automatically, because we're touching faces and edges of the shell body. It automatically assigned to bounded. Okay. In the simulation study tree, we're going to create a mesh. Right click, create a mesh. So we are going to use suggested values. Hit OK. You can see the mesh has been generated. Okay. Now we will be able to run the simulation, run the study. Okay. Now we can see the results. Okay. So right-click the results. Before we go further, we can look at already included before we go further, we can look at what we have already included in the results. Let's turn back. Okay, now you can see the stress. Okay, it's a stress, run mesh stress distribution, and this is displacement. You can see displacement is two corner close to 0 because we have a link. The strength. Okay. All right. So let's see in the results. We define stress plot. Right click results. Define stress plot. And then use SX, normal stress, and use PSI at the top, and definite shape. We use user defined, and we would like to use 1 as our scale factor. Hit OK. Now you can see very small deformation. Okay, 1-to-1 deformation have been shown here from view. Okay, so and the stress concentration is high, right, as being described here, where the shell meets the solid, right, which is this location. Right, the top face of the shell exhibits compression at the interface with the solid. Okay, right, because this is minus. The minus indicate. I think this is minus sign. Right. Okay. This is the new stress distribution. Define a similar stress support at the bottom. Okay. Click, define. Okay. This time is the bottom, PSI. Scale. Okay. Alright. Then you can see the stress at the top and the bottom are different. Right. Alright. Then in the result we're going to define displacement plot. Define displacement plot. And in this space, users result displacement in components, unit, select inches, unit, hit OK. Between the link, notice the distance between the link to vertices remains constant. Right, so we don't see any deformation here. Right, the linked in constraint. Okay, this is the end of the tutorial. You learned how to use a tutorial in SolidWorks to study, and also you learned how to use a shell mesh to simplify your analysis.